Good morning, everybody. We're just going to let the numbers get up a little bit before we start. We're just slightly before 10:30. So just let those who are getting a cup of tea or whatever. Okay, that's 10:30. Numbers are still going up, but I think I'll kick off. So first of all, good morning and thank you so much for joining us for this ORE Catapult and ESA webinar. The rationale for this webinar is to build trust and awareness and commercial momentum around autonomous space-enabled marine systems. We're aiming to bring together players across industry, academia, and public sector to create pathways to technology validation and market development. Next slide, please, Olivia. This is the first in a series of events, and next year we will run 3 in-person events, which will be in Wales, most likely Cardiff, the Southwest, most likely Plymouth, and Grimsby, to dive deeper into the issues that matter most. From today's sessions, we're particularly looking forward to capturing your priorities, the challenges, the blockages, the opportunities, your ideas, so that we can focus on those to shape the upcoming events. We have a very strong lineup of speakers today representing the main sectors, with a good emphasis on the technologies that are actually out there doing it. As we go through the session, please use the Q&A function to share questions or observations or key issues. And even if we don't get to many of those live today, we will follow up afterwards and we will use them to keep the conversation going. I'd also urge you to join the Celtic Sea Cluster, stood up in 2021 specifically to support and represent the supply chain. It's free to join, and we have a newly commissioned members area on the site so we can facilitate members speaking to each other as well as us. So next slide, please. Here's a preview of today's agenda. So we'll begin with a look at where autonomy is in terms of a wind farm developer's perspective, move on to the ESA view and some initiatives and projects and views from within the scientific space brought to you by my colleague Marie and Professor Matt Witt. My colleague Ampere will then contextualise robotics within offshore wind, including a look at operation and maintenance sector. From there, we move into presentations from highly innovative technology developers. Each will be showcasing their work, both testing work and real-world deployment, which is taking place in different parts of the world and addressing a range of challenges. After which, Ashley will talk about the ways and means to creating a clear and enabling framework for maritime autonomy. Our final sessions will address the crucial issues of the funding landscape, with insights from both Innovate UK and ESA on what support mechanisms exist and what's evolving. Grant will bring the webinar to a close, and if time allows, we'll take the opportunity to address any key issues. Many thanks to Olivia, who's behind the scenes making this run smoothly. I hope you enjoy the day. Next slide, please. Firstly, I'd like to introduce the Catapult Network, and in particular, the Offshore Renewable Energy Catapult, and our role in advancing space-enabled autonomy, how we can work with you, and how together we can help shape this agenda. The Catapult Network was created to accelerate the translation of research and early concepts into market-ready solutions, turning cutting-edge technology into real-world impact. There are 9 catapults across the UK, each focused on a key sector, and we work closely and collaboratively across that network. Next slide, please. The Offshore Renewable Energy Catapult, or ORE Catapult, is dedicated to driving innovation that enables an abundant, affordable, clean energy. We have teams driving innovation and working with the whole supply chain throughout the UK. Next slide, please. In Blyth, Grimsby and Aberdeen, we have world-class facilities, developing and testing the technologies of tomorrow on all of the key areas, from high voltage electrical equipment to blades to drivetrain and dynamic cables. At Levenmouth, we operate our own offshore wind turbine. It not only generates power, but also provides a unique test environment for new technologies in real-world conditions. Next slide, please. In Blyth, we host our Digital, Autonomous and Robotics Engineering, or DARE, Centre. That short video showcases some of the facilities, many of which have been purpose-built to support autonomy development. And that's a good overview of our real facilities, but we've also developed Virtual Dare, or VDARE, which is the first true-to-life simulation platform of its kind in the offshore industry. It's designed to fast-track the deployment of robotics and autonomous systems for offshore wind applications. I suspect my colleague Ampere will cover that in more detail. One of the key initiatives for offshore renewable energy Catapult that truly relies on space-enabled technology is our Accelerating Consenting for Offshore Renewables Deployment, or ACCORD project. This project originated from this critical observation that it currently takes longer to consent a wind farm than to build one. Next slide, please. We believe the solution to this conundrum lies in the deployment of smart technologies that have been validated, tested, and demonstrated. This not only supports faster and more confident consenting, but also opens up a significant market opportunity for the UK with clear potential and global application. At the heart of ACCORD is the development of a flexible, user-centric data portal for offshore wind datasets, feeding into a digitized environmental impact assessment process. The rapidly evolving autonomous systems we're seeing around us today naturally fit this, offering persistent, comprehensive monitoring with significant spatial and temporal coverage, giving richer, high-resolution data to inform decision-making. This technology will naturally support a regional ecosystem approach, and my colleague Marie will cover that in more detail later. Next slide, please. As part of the ACCORD project, we have published 2 comprehensive reports, both of which are available through our website. Next slide, please. We see the Catapult role in all of this as working with our partners, which includes Plymouth Marine Lab and the University of Plymouth and others, to build a database of platforms and sensors, to develop methods to demonstrate the value of this technology, and engaging with statutory nature conservation bodies and policymakers to build confidence in their use. We're building a network of innovators and developers from both the technology and wind farm sectors to de-risk the consenting process. In essence, ACCORD is about bringing together technology, data, and collaboration to help unlock faster, evidence-based offshore renewable deployment. Next slide, please. Please either use the Q&A to contact us or contact me or other colleagues directly, and we'd really like to keep this conversation going. I'm very pleased now to pass to Tom Nightingale of Equinor, one of the successful bidders in the Celtic Sea Leasing Round 5. Tom, over to you.
Thank you, Julie. Hi, everyone. I'm Tom Nightingale, and I'm the UK Supply Chain Manager for a company called Equinor. We're an offshore wind developer in the UK, but we've been working in the energy industry for many years. And one of the things that we've been trying to do is to transfer some of the learnings we've had from other areas like oil and gas to offshore wind. And a lot of that is through digital solutions, which I'm going to talk about now. So if we go to the next slide, please. So Equinor has quite a strong vision to be a digital energy company. And what we would like to do is to be able to use data um, not only to make better decisions, but also to be able to drive the way that we perform things like operations and maintenance. We have projects which last for many years. For example, our Dogger Bank wind farm, we've already confirmed will have a 35-year life. So there's lots and lots of ways that we can use data now to plan our systems and processes to make sure that we can perform that as effectively as possible. And some of that will be to drive better safety and security, but it will also be to use technology like robots to make our work easier. And what we want to really be able to do is to have people working with technology in order to advance us as an industry leader. Go to the next slide, please. So we think the future will be robotized, automated, and connected. And we've got a very strong vision of using things like drones on our different assets, maybe our service operation vessels out in the field, but also even to do things like deliver parts to our wind farms. And we think that it could really help us with repetitive tasks and high risk operations so that it reduces safety incidents for our people and makes sure that our people return home safe, which is our priority. But it also might free up time and the creativity of our workforce in order to develop better solutions. And we've got projects all over the world, so this could help support our global operations by optimizing performance and connecting our operations knowledge and expertise. So it's something that we really believe is an important part of our business as we move forward. Go to the next slide, please. So like I said before, we've got different parts of our business. Areas like oil and gas, renewables, and low carbon solutions. We're developing lots of low carbon projects as well. But we also need to think about the solutions now that we develop for these existing business areas can also be transferred to emerging and future business areas. We have a big focus on power at the moment within Equinor. So lots and lots of new types of projects like batteries and thermal power coming into our business as well. So we really need to have a digital platform that covers all of our existing assets, but also can easily have new areas plugged in as well. Go to the next slide, please. So we've got a project internally called Autonomy, Interoperability and Robotics. And this is trying to look at different parts of our business. So things like in the air where you might have a drone. So that could be looking at advanced analytics. But also what we want to be able to do is to have a digital twin so we can perform things like access to a turbine tower and how you might use a drone instead of a person to perform operations and maintenance, but be able to look at that from our control rooms on land and effectively make the decisions about what is the best way to perform an activity from shore. And that could also be on the ground, so using robot solutions like you can see there. And also, especially I think important when you think about space is things like network and communications. So there's a big focus on 5G, and we already use things like Starlink across our fleet of service operation vessels for our wind farms, taking advantage of that connection between what we've got in the sea and on the land with what's happening up in space, because there's lots of opportunities now to be able to use these fantastic new technologies like Starlink. If we go to the next slide, please. This is just an example of where we're really able to put this vision into practice. So there's a company in the northeast of England called Modus Subsea Services, and we signed a contract with them to have the first resident subsea drone, which is being trialled on one of our oil and gas fields, but could easily be transferred into offshore wind. So this covers underwater intervention drone operations, and you can see a picture of the drone there, which will be able to live in the field, so it can go and charge in the field, and then it can go and do more survey work, and then all of the data is transferred back to the mainland, whilst the drone can just stay in the field permanently, which saves a lot of money from deployment costs and using vessels as well. So some of the things it can do is light interventions, over the horizon control, and again, it can reduce the need for having people out in the field. Although what it does do then, it creates new different types of jobs on land where you have people who can use all of that data and help to make more informed, better decisions from that data. Next slide, please. So that was my final slide. I'll now hand over to Mina from ESA.
Good morning, everyone. Thank you, Tom. Today I'm just going to be giving you an overview of what we do within the energy vertical at the European Space Agency. Next slide, please. Basically, I'm not going to, so the European Space Agency develops and applies space technology for peaceful purposes in general, driving innovation and delivering solutions that benefit society and industry. So basically here, I have an overview of our program, of our specific program, which is called ESA Space Solutions and Business Applications, and how we apply space technology across a variety of markets, being energy one of them, and it's the one basically that I'm leading across the department. At the European Space Agency, we just don't focus on space for the space sake. We use space technologies like satellite communication, navigation, Earth observation, and space weather to create real-world impact. So our work spans across multiple sectors, from energy, transport, agriculture, healthcare, finance, education, and the list goes on, helping industries become more efficient, sustainable, and connected. Combination of these space assets and technologies, as we call them, with emerging technologies such as Internet of Things, artificial intelligence, machine learning, robotics, or even blockchain. So together, these capabilities really allows us to support businesses, enable new services, deliver meaningful solutions that benefit both the economy and the society. We can move on to the next slide, please. Exactly. Thank you. Just a quick snapshot of why we're focusing specifically on energy, because basically it lies at the core of Europe's transition to a sustainable and resilient future. So as the global demand increases and the effects of climate change and intensify, achieving cleaner, more efficient, and more secure energy systems is very essential for everyone. So this aligns directly with the EU Green Deal, which I'm pretty sure you're all familiar with, or with the Paris Agreement, which actually sets really ambitious goals to reduce emissions, at least 55% by 2030, and as you pretty much all know, reach climate neutrality by 2050. So in order to meet all those targets, we really need innovation, and this is exactly where ESA plays a key role. And specifically our department, because we're very focused on commercialization and supporting all those industrial players. So through these space-based digital solutions, we really help monitor energy infrastructure or optimize renewable energy through space-based and digital solutions. Satellite technologies in general enable better planning, forecasting, monitoring, and supporting the shift towards cleaner energy, and helping Europe stay basically on track within those goals that I mentioned before. We can move on to the next slide, please. So basically, a few years ago, we created the so-called Energy Task Force because collaboration is key in order to accelerate the clean energy transition. So since not a single organization, of course, can really tackle the energy challenge alone. So for this reason, we really, put together all those like big entities in order to, let's say, combine the expertise, our space expertise, the expertise from industry, but also from the policymakers. This task force basically brings together leading partners, across the energy sector. As you can see, we have big names here like AREG, the COMSI, German Energy Agency, Indian Energy Storage Alliance, and the list goes on. From grid operators to technology centers, sustainable networks, and innovation agencies. So all together with them, we try to promote a sustainable green economy using space technologies and to amplify impact through collaboration with lots of different other energy stakeholders at a global scale. Basically, by leveraging ESA's space capabilities, as I mentioned before, the space tech data like Earth observation, navigation, or communication, alongside with their expertise as our partners, the task force really tries to help drive innovation, resilience, progress towards Europe's climate goals towards 2050. We can move on to the next slide. Actually, these are our priority areas because in collaboration with all those relevant stakeholders, we have identified a range of categories of topics, of opportunities, as we call them, within the energy sector, where actually space could facilitate innovation. We have those 8 topics that we call them the overarching topics as part of our energy roadmap. As you can see, they're very broad. And the reason why we keep them so broad is because, yes, we want to introduce those topics to our audience, but at the same time, we want to keep it flexible for the industry coming to apply to our program to propose their own ideas. These are topics that we have been developing for the past couple of years, and the aim is to expand this portfolio of topics with additional ones. And we can move on to the next topic, to the next slide, sorry. This is a quick overview of a report, the Energy Dossier, that we published a couple of years ago, beginning of 2024. Basically, this dossier includes details of what is the role of space in the energy transition, as well as the information about projects and initiatives that have been supported by our program, and of course, the plans for the future. As you can see, we have divided those different activities based on different topics, starting with energy generation, storage, operations, and decommissioning and circularity, with the highest amount concentrating specifically on operations and maintenance and planning. Overall, we have supported 47 activities, meaning both studies and demonstration projects, which vary across the different types of TRLs that we support, from 15 different member states, and we have invested 34 million in total. Earlier this week, actually, we also published the Green Hydrogen Focus Report, which also dives into the huge potential of space applications to accelerate the adoption and scaling of green hydrogen. I have to say, watch the space, because we plan to publish 7 more focus reports reflected on the topics that I presented in the previous slide. And that would be all. If we move on to the next slide, which I think this is the closing one, in case you would like to reach out or have any questions, feel free to reach out. Thank you so much. And I pass on to Marie Kelly.
Hello, everybody. I'm Marie Kelly, and I'm going to be presenting initially on 2 things. One, the REMP record, which I'm actually presenting on behalf of Caroline Worley, our environmental specialist. But she's in America at the moment, so timings don't really suit very well on this. So I'm just going to do a bit of a run through about the report findings that was published earlier this year in November, and then go on to one of the projects that we've got. So next slide, please. So the report, as I said, published in November, and it documented a framework for regional ecosystem monitoring program, or REMP, as it's been termed. And I'll run through these recommendations of it now and how it feeds into them, what we're discussing today. So there is a need to overhaul how the offshore wind development sites are monitored, shifting from project level EIAs to regional scale monitoring, which would remove overlap and duplication, reduce project management costs, improve accuracy of cumulative impact assessments. It would also help to address the resourcing issues that hinder the organizations responsible for regulatory decision making. The regional in the term refers to the collective project development areas as designated by the Crown Estate, as well as the wider zone of influence, which includes impacts outside the development footprint, the proposed cable route corridors, and grid connections. Thirdly, we've got government funded but hosted by an independent facilitator. The costs would eventually be recovered indirectly in the tender from the winning bidder, similar to the process we have in other countries such as Germany. So to then remove the scoping phase from the pre-application stage, regional advisory groups would be then established to engage on environmental engineering concerns and in collaboration with key experts from academic institutes and statutory consultees. Current environmental monitoring has provided a large amount of data on environmental effects at the species level, considering the sensitive of potential disruptions to distinct receptor groups such as marine mammals, birds and fish. It is essential that a monitoring plan for offshore wind farm is designated to detect changes within the ecosystem at multiple spatial and temporal scales. Ecosystem-based monitoring can then be used to monitor the biodiversity and functioning of an ecosystem, including changes that may occur due to offshore wind development. And as part of these suggested changes, we would look into adopt an ecosystem-based approach to monitoring driven by key indicators and monitoring priorities specific to each region. The transition from current monitoring methods to make the use of innovative technology compared with traditional in situ observations by ships and moorings, and the greatest strength of autonomous platform networks is their capacity to conduct multi-scale and cross-disciplinary measurements. Such resolution is critical for a regional scale monitoring program. These data sets and model output should then be open access to ensure information is genuinely useful and can feed into other policy and management measures such as good environmental status and marine protected areas assessment that promotes sustainable development of the marine environment. So next slide, please. That development process then that is laid out in the report is to initially establish an advisory group to lead monitoring design and implementation, to determine the key indicators and monitoring priorities and set out the key scientific questions of the plan. Then you define the appropriate spatial and temporal scales for each survey, and this is for each region, again, to make it designed fit for purpose monitoring program, making use of novel methods and suitable scales, temporal and spatial for that region. So they then collect and collate the data using agreed methods and formats, ensure the standardized approach across all regions, and then facilitate the data sharing. Next slide, please. So some of the consenting issues that were identified and then the benefits against the REMP report that have been laid out. So for the offshore wind industry, there's uncertainty in consenting times, uncertainty in the quality of data, competition between developers, availability of resources for monitoring and analysis, and high costs. And the benefits of REMP against these, we think it will streamline the process, it will give more certainty. It can potentially remove the scoping phase if the data was available. People could be able to just buy into it straight away. The smarter, innovative technology and AI data processing will collect more robust data. Regional monitoring could reduce competition for the resources, transparency in data sharing, standardization of analysis and outputs, the flexibility in monitoring methods and streamlined EIA reporting so it can reduce resourcing issues and reduce costs on project management, consultancy fees and discretionary advice and monitoring because of the streamlined pre-application process and process of the whole thing. For the regulator and the SNCBs, that would be problems and issues are resourcing, workloads, uncertainty and environmental impacts. And again, if we continue this and follow this method, we'd have improved understanding of the effects and significance of the impacts. As we get that cumulative picture over time, we'll be able to reduce the regulatory burden with a streamlined pre-application process and reduce the administrative burden as well from standard EIAs and have greater consistency in the quality. So for the academic community as well, there'll be timely data sets. They're free, available for research. So that expands out the amount of research and understanding that everybody can do on it. If you can just go in and access that for that regional thing, what we'll learn from those sites is huge. So the value of that is really good. Then the business community as well will build a regional and UK-wide supply chain and a global export opportunity. Next slide, please. Okay, so that's the overview of the REMP report. And then one of the projects that we've got is the Subsea Soundscape program. This is currently funded by the OWEC program, part of the Crown Estate, and it's partnered with Exeter University and Celtic Sea Power. Matt Witt's the lead from Exeter and Neil Farrington from Celtic Sea Power. I think Matt Witt's actually next in line to speak as well. So so the Subsea Soundscape program is pioneering a regional framework for the Celtic Sea. We are mostly focusing, although, on underwater noise conditions, not the whole ecosystem at this stage, but we're also collecting eDNA and CTD environmental sampling as well. And we'll be comparing this with looking to install these So they're seabed mooring units, which actually Matt installed last week, all across. So they're actually all out now, 21 stations across the Celtic Sea. Seabed landers equipped with state-of-the-art broadband acoustic recorders. Next slide, please. So you can see here in the maps all the green spots. I think they have slightly changed. This is not the latest map that we have. The green points are the ones in English waters, and the red are in the Welsh waters. We will, like I say, it's just been deployed. So it's 21 acoustic monitoring stations. It will give us a new marine mammal evidence base for the Celtic Sea. It's going to be out there for 2 years. So it'll create a region of acoustic soundscape model and open source baseline acoustic data. So we'll be releasing this data on a quarterly process once we collect it and collate it and put it out onto the Marine Data Exchange. So that will be available to everybody. Alongside this, we're also going to be co-developing roadmaps with regulators. So that's going to start in the new year. We'll be holding workshops in Wales and in England to work at how do we use this data and use this approach to consenting. And then we're also going to be comparing, part of our reporting back to Crown Estate is comparing that regional approach to data gathering to the industry standard for collection, and that's in difference in carbon, cost, time, safety, and again, the eDNA and water column physics will be going to be used to help cross-validate DAS data, visual, satellite, and acoustic techniques as well. Next slide, please. This is it has slightly changed, this picture on the right hand, but that is the seabed lander that we have installed out, and they say they've got FPODs and broadband acoustic recorders on there as well. So they're sitting out on the seabed. The impacts we're getting measured for by OWEC are we've got to reduce the consenting time. So we've got to use identifiable use of the data that we produce in consents and applications, and a displacement of project scale surveys. We're going improving coexistence and reduce environmental impact, and influencing policy and more efficient use of the seabed. So we'll be reaching out to everybody over the next few months, where we try to set up some of these and start working through our plans to do the reporting on how we use this data across. So next slide, please. And this, it's final closing. So this is the other groups of our member of our advisory board that all feed, some of them again that are on this call, that all feed in and support us with what we're doing on this project, and we'll hopefully be taking part in all the workshops to deliver the advice. So thank you very much, and please reach out to us if you have any questions. We've now got Matt Witt from University of Exeter.
Hello there. Thank you for the opportunity to talk. Could I have the next slide, please? So you might ask why I'm here. So from an academic perspective, I suppose you might imagine in universities we're charged with understanding knowledge acquisition. So that's epistemic kind of approaches. So really in the renewable industry since 2008, my work's focused on understanding the interactions between renewables and biodiversity. And we've tried to do that from an independent kind of distance standpoint, so that the information we offer kind of has that sense of independency. But really, I think the academics' role in this webinar, or in this whole area of work, is really to offer insight into things like methodological transparency around the use of autonomy to gather data in the renewables sector, to look at issues and discuss challenges around reproducibility. How can these tools provide data again and again and again, is desperately essential if these data are to be used to help understand how marine ecosystems respond to the deployment of wave devices, wind energy, and tidal. I think our real goal, though, is really to push the industry in that broadest term, to look at how we seek data for peer-reviewed science, because using that method typically leads to the strongest types of data that can underpin decision-making, in contrast perhaps to kind of independent or project reports that might be produced from actions undertaken by companies, but those work not necessarily subjected to peer review. So I think that's what the academic perspective is and why we're here. Next slide, please. So I think it's kind of key for us to recognise that we need to understand processes that operate at sea at all scales. And that's a formidable challenge, but actually autonomy is brilliantly suited to help in this challenge. So we kind of need to understand what goes on at the regional scale, as Marie's just spoken about. That's really quite important. That works over hundreds of kilometres and years to decades, because these are the spatial scales that animals live at, both spatially and temporally. And as there's a greater drive for cumulative assessment and that burden placed on developers, you really can't do cumulative assessment very well unless you know what the responses are to wind farms of those wind farms that are your neighbours and that came before you. You kind of need to understand responses at the scale of wind farms over seasons to years. We need to understand processes at turbine scales, that's at meters, and that's kind of time scales of continuous to daily. But we also kind of need to understand at sensor scales, centimeters to meters, because these are really the devices that generate data from which people then make decisions upon. So while sensor scale work might seem nuanced, it's really quite essential when you're looking at things like uncertainty. But the key thing, I think, is that integration is really key. And that's integration of what autonomy and those types of devices can deliver us. And that's recognizing also that autonomy itself will not answer everything. Even into the future, there'll still be a role for moored stations, spaceborne observation, and ship-based science. And I mentioned ship-based science here very quickly because the drive for autonomy may actually end up de-skilling workforces from being able to do ship-based work when it's subsequently needed in the future. And so I think integration is key. Next slide, please. I don't really expect you to read this table, but these are the types of things that we kind of challenge ourselves in academic institutions to think about: platform types, strengths, limitations, their best use cases, largely because we're seeking to understand how you can integrate data and always ensure all these types of platforms continually deliver data that is fit for purpose for scientific research. So satellites providing synoptic long-term data, ASVs providing data in real time. They can take larger payloads. You can also do kind of dipping science where sensors can go into the sea, but recognizing that they sit alongside things like fixed platforms, which can give you much more continuous time series data, much higher resolution, but have very poor spatial coverage. Next slide, please. So what are the rigors that we require from scientific investigation? I'm sure you're probably all quite appraised of these, but largely it's repeatability. We need long-term monitoring. Autonomy can certainly help with that. And that's certainly important for compliance post-construction. Standardization, if you bring in multiple external companies to run your surveys for you year on year as part of consenting agreements, you want to make sure there's instrument intercomparability. You want to look at issues around data quality and calibration. It's really quite important to understand these challenges from the perspective of uncertainty quantification, like how good are your sensors at telling you what's really happening out there? And that uncertainty extends from sensors to platforms, right the way through to how you then interpret those data in the environmental context. And we also concern ourselves or worry about issues around validation. So how do you ground truth data in situ and from satellites? But I think the key point from the slightly kind of stood back from it is that I certainly think marine autonomy can certainly enable all of these things to be done, but also represents new challenges to meeting these requirements that we ask for in scientific investigation. Next slide, please. So really just to kind of wind up then, I think there's a very important role for autonomy, certainly from a perspective of data fusion and assimilation. And you can see from this slide, I've kind of put satellite, ASVs, AUVs, fixed platforms and vessels. We should look at and be challenged by issues around integration and data processing, but really they can help in that integrative approach to things like resource assessment, site characterization, environmental impact assessments, and operational support. because from that data fusion perspective, it addresses things such as observational gaps across scales of time and space. They enable cross-validation, uncertainty reduction. Ultimately, autonomy contributes into a holistic understanding of these ecosystems that we perturb by putting large-scale civil engineering projects into them. But really together, when we assimilate, we can support reproducibility and provide scientifically defensible assessments that ultimately, I hope, make decision-making that little bit easier. And final slide, please. Thank you very much.
Morning, everyone. My name is Ampere. I am going to be talking today a little bit about some of the roles that robotics is already playing in the offshore wind industry. So we've already heard some of the benefits for using robotics in different industries, and of course in the offshore wind industry. So some of the benefits, including things like improved health and safety, increased accessibility, and there are all these additional benefits we can achieve through the use of robotics. So, for example, robots can handle high volumes of different tasks. They can do things quicker, they can be a bit more accurate, and of course they can handle harsh environments. So a lot of the applications that you may hear commonly about robotics in offshore wind is in the area of environmental monitoring or operations and maintenance. But broadly, robotics can apply to almost every section of offshore wind, from site selection to installation to decommissioning. So today I'm mainly going to be talking about and giving a lot more of the examples around O&M and also around some of the environmental monitoring side, but there is a broad perspective here of how robots can be used in the sector. So next slide, please. So first, I'm going to just give a few examples of some of the different types of robots and some of the examples of the roles they are playing in the offshore industry. So the first one we will talk about is unmanned aerial vehicles. So a typical type of this robot is something like a drone, which is very good at carrying out things like structural inspections, blade inspections. They are able to carry out other activities like environmental surveys, and they are quite good because they are able to achieve faster inspection. But they do have some limitations in terms of the time of operation, things like how much weight they can carry, and also some challenges around regulations like BV loss, which limits how these aerial vehicles can be applied. Next slide, please. So another type of robot which is often used, which is being used, is stationary and mobile ground robots. So these are examples of this is sort of like the quadruped with the image shown. These can be very flexible, so they can be configured to have different types of manipulators and different things on them to carry out different tasks. They are quite flexible in the way they operate, and they can be used in locations like in the nacelle to carry out different O&M tasks around both inspection and carrying out small maintenance activities. But some limitations on there also include the fact that nacelles of wind turbines, for example, have very complex layout, and it can be quite difficult to maneuver some of these devices through the very complex layout, but they still can make a massive impact in the O&M. Next slide, please. So another type of robotic device is the contact and crawler robots. So these are typically sort of like robots that roll on a blade, for example, as shown in the image, and they're able to make contact, and so they can carry out inspection activities. But some of the ways that they are being co-opted now is to look at, can they carry out repairs? So they bring a lot of benefits. For example, when it comes to blade inspection, these are able to save us from using rope access technicians. So these are technicians who are highly skilled, and there's a limited number of rope access technicians. So if we're able to deploy more of these contact crawlers, they are able to solve a huge problem for the industry. Also, one of the advantages there is that they can kind of crawl on vertical surfaces, which is one of their strong points. So they can crawl and inspect the blade both internally and externally, vertically. Next slide, please. Then another type is the unmanned surface vehicle. So these are devices which practically often mimic something like a boat, which is like an autonomous boat, which operates on the surface of the water. So typically, these can be used to do activities like seabed surveying or marine life assessment, things like that. But they can also carry out activities including structural inspection, both on things like foundations or cables. So they are relatively mature technology. So that is a big advantage in terms of they are a technology which is ready to be used in a lot of different applications, but they do still have some limitations in terms of the weather and sea conditions that they can safely operate in. There are some issues around regulatory compliance for autonomous operation in offshore waters. But these devices, as I said, are relatively mature and are currently being used in the offshore industry. Next slide, please. And I think the last but not the least group is the unmanned underwater vehicle. So these are used for carrying out inspections underwater. So for example, for offshore turbines, these can be used for carrying out inspections on be it cables or be it the foundations underwater. They can also be used to carry out some environmental monitoring activities. And example of this is sort of like the ROV, which is a relatively mature technology, which is already being used in other industries for years. But they do still have some challenges that need to be resolved around some of the areas around navigation, some of the underwater communication. Sometimes these may be tethered, like in some ROVs, but in the future there can be fully autonomous unmanned underwater vehicles which are able to carry out tasks without the need for any tethering. Next slide, please. So we covered a whole range of different types of technologies, and I wanted to include this slide just to show that the different technologies can be put together to address certain different issues. So around things like consenting, we can apply different types of robots for doing so many different types of activities. So for example, we can use UAVs for monitoring birds. We can use some of the AUVs for high resolution acoustic and sonar mapping of the seabed, for example. And there are so many different applications that we can use these robotic devices. Next slide, please. So I included this slide just to talk a little bit about some of the future trends. So I talked about, for example, some of the contact crawlers being able to do inspections on blades. So that is something which can be done, but one of the areas which still is a bit challenging for a lot of robotic devices is they can do the inspection, but they are not so great at doing the repair. But there is a lot of activity going on in this area of looking at how can you use robots to repair, not just inspect. And so there's quite a lot of activity in that area. So we also talk about some of the limitations around navigation. For example, in some cases, especially if you want to use robotics for inspecting the inside of a blade, that is a GPS denied environment. So you don't have GPS for aiding your navigation. So there's quite a lot of activity going on around how do you best navigate this robot to carry out the different tasks that you want to do with the limitations that already exist around things like the GPS denied environment. There are some activities around regulations around BV loss, which is also ongoing. Also, in order to deploy a lot of these robots, it is quite challenging. So you need special or very specific equipment to allow you to deploy this environment. So for example, if you've got a contact crawler, you need to be able to get it all the way up on top of a nacelle and then deploy it onto the blade. That is a particular challenge. So these are all areas that are currently being researched, and loads of development going on in that area. There's also the concept of teleoperation and residential robots, which are going to be a part of the offshore industry in the future, which is having robots which practically basically just live on turbines. So they perform all the different tasks and they live on the turbine and carry out operations and maintenance activities as and when it's needed. So that basically saves a lot of costs and health and safety risk in terms of getting people onto turbines to perform activities. And one last thing that I wanted to also mention is around simulation for the robotics development. Julie mentioned earlier about our VIDA facility, which is a digital environment for simulating robotic applications. So, for example, if you want to know what's the best way to maneuver a robot, you can do that in field. but it's normally very costly and time consuming. But this provides a bit of an environment where you can do that in a relatively simple virtual environment. It allows for you to validate some of the controls that you may have and check that it's performing just like you would in a virtual environment before you deploy in real world. So last slide, next slide, please. So just wanted to also point out a few areas of challenges for autonomous devices. So as I've shown, there are loads of potential applications, some of the future trends going for offshore robotics, but there are some of these challenges around regulations, things like data transmission, for example. Data storage and analysis. How do we best use AI to process the data we get from, say, drone images? How do we use AI to help maneuver the robots in the best way to achieve the most optimal kind of inspection and repair? And the last bit is talking about the survey market. So there's not a lot of companies who are involved in the activities around robotics for offshore renewables. And so there is a strong need to make sure that we interact quite well from research to commercial organizations to make sure that all the basis is covered. And one of the key things that I will say as the last thing is the need to develop more skill. At the moment, there is a huge skill gap. And in order to achieve the future potential of robotics for the offshore industry, we recognize the fact that we need to hugely upskill the industry in the ability to employ these technologies. So I think that's my last slide. So over to you, Anahita.
Hi, Anahita, just before you start, sorry to interrupt you, I did pop it in the chat. If people could use the Q&A function, not just for questions, but for anything that you're seeing or hearing, anything I'd like to know more about that, or I disagree with that, or particularly as we enter this next phase of presentations, because we're going to really see this technology being deployed by the people that have innovated it and invented it. Thanks. Apologies.
No, that's quite all right. And hi everyone, next slide please, if you can bring up the title. I'm Anahita, I'm the CEO and co-founder of Ocean. In this kind of quick overview, I'll explain a little bit about our devices, the Seastars, because they're quite different, give you an indication of what they can do, talk you through one of our most exciting projects, and then talk about kind of how we envision these sort of devices being rolled out at scale and how that could be beneficial to offshore energy. Next slide, please. So at a high level, we make these small 1 meter long robots that are called Seastars, and then we deploy them in constellations for wide area long duration monitoring. I think the two most kind of important things to bear in mind about these robots is firstly the propulsion method. So in order to make them operate at sea for long periods of time and not be constrained by range, by battery capacity, we use wind for propulsion and then a combination of battery and solar to power the onboard sensors. And then secondly is the scale of them. So these robots are just over 1 meter in length. This is really important for a couple things. So because they're really small, it's easy to kind of deploy large swarms or constellations at a reasonable cost. It makes it easy to deploy without equipment, so a human could kind of lift them overboard. And it also makes them a low risk profile to other water users that might be out on the ocean as well. Next slide, please. So this map shows a few of the different locations around the world that we have previously operated. And the applications, each of those kind of triangles represents a Seastar. Each of those applications I'd maybe split into kind of 2 buckets. The first bucket is metocean data collection. So this is monitoring data like wind speed or other metocean variables, for example, for resource assessment, but then also monitoring things like significant wave height, which could be a really key parameter when you're wanting to deploy quite sensitive and expensive equipment. And then, so that's the first bucket, kind of metocean data collection. The second bucket is passive acoustics, to essentially collect data on what the underwater soundscape looks like, which has been touched on earlier on in this webinar. So we've done some work in the UK, primarily on bottlenose dolphins, deploying sea stars with hydrophones attached to listen to the high frequency kind of cetaceans such as dolphins. But we wanted to push further afield and do the kind of more difficult to sense side of cetaceans and focusing on whales, in particular, the slightly more endangered species. Next slide. So an example of this is on the west coast of the US, a research institute called MBARI leased an Ocean Sea Star, and we did a project with them where they ran an assessment of the ability for Ocean Sea Stars to be deployed operationally and collect data on the presence and absence of humpback whales. It was a successful project. We collected good data and showed essentially that sea stars can kind of detect presence or absence of a wide variety of cetaceans. But I also thought an interesting thing to mention here is actually the collaboration with scientific institutions, bearing in mind what Matt Hill from Exeter was saying, in that actually we're a company primarily of engineers, and it actually was really, really helpful to have this scientific research institute using the Sea Star, because they were much better at looking at the data and actually telling us, look, this is actually quite noisy, you should think about repositioning your hydrophone like this. And that actually massively accelerated both the trustworthiness of our data, but also the data quality by getting that feedback very early on in the company's history and then kind of iterating accordingly. So that's a really strong thing that I think is very beneficial for industry, both to do now and to do kind of working forwards in the future. Next slide, please. So a key issue that I think has already come up and I expect will keep being a theme in this webinar is that part of the reason we have this slow process for consenting an offshore wind farm is the lack of kind of a solution for long duration and wide area data. You know, we have moored buoys, which can do a really great job of providing long duration data in one precise location. We have satellites, which are great at kind of providing some data sets, but not necessarily all the data sets you want. There's nothing that kind of does the over the course of a whole year and over the wide area of an offshore wind farm type data. And at Ocean, we essentially think that in order for autonomous platforms such as Sea Stars to actually be useful to solve this problem, we have to do two things correctly. We need to make sure that our platforms have endurance. So collecting data for a few days over summer is not good enough. You need to be able to operate for multiple months over winter. You know, the cetaceans don't all go away over winter. You need to be there collecting data on them all through the year. And then the second thing is reliability. You know, you need to keep doing it over and over again. You can't do these one-off missions. You need to be able to show complete reliable operation. So this is what we think is really important, and what essentially a lot of the first few years of the company's history has been focused on solving. And on the next slide, please, I'll be able to give a really fun case study on some of the more exciting work we've done here. So the best illustration of endurance and reliability is the mission that these 7 Sea Stars circled here have done. So this was on a project with NOAA, which for people that don't know is a bit like the US version of the Met Office. And they contracted us to deploy 7 Sea Stars, primarily collecting metocean data, so essentially weather data, with the goal of being able to collect data in hurricanes. So step 1 of this project was the Sea Stars sailed out from the Caribbean. Some of them had to go 400 miles fully autonomously, so covering quite a big distance. And then they kind of sat there for about a month waiting for a weather event to kind of come and take place. And it did take about a month before something kind of really nasty popped up. And on the next slide, please, I'll show you what that looked like. So after about a month of station keeping in position, after doing that 400-mile transect, we did have, well, in our way, we got lucky and had a Category 5 hurricane start to head towards these Sea Stars, who then all autonomously sailed into position to try and intersect this weather event. And this was exactly the goal of the project, probably the only robots that were happy to kind of go towards a Category 5 hurricane. And on the next slide, I'll go through a couple of the outcomes here. So the very exciting one that I'll be telling everyone about is that we've now become the first surface robot to collect data in a Category 5 hurricane, the worst type of hurricane you can physically get. And just to kind of put that in perspective in terms of the weather experienced, the gusts were hitting 140 knots, so like twice the speed of a car on the motorway, essentially. Pretty nasty. And the data was used operationally by the National Hurricane Center to put out their forecast advisory, which was nice. But the most important thing here is essentially the multi-month missions and the ability to operate in the worst kind of weather that you could possibly get at sea, which is crucial if you want to show both the reliability year-round and the endurance for multiple months. Next slide. So to conclude, I think what we'd like to say is that we believe, the potential of long duration wide area monitoring could be a game changer for understanding the ocean conditions and understanding the ocean soundscape, and getting that kind of rich picture of data. And we believe this was only quite recently possible as well. So the first wave of ocean robotics, they all kind of focused on the much larger autonomous vessels, and they kind of were just looking at substituting and doing the work that manned ships used to. For example, hydrographic survey and all of the work that we're kind of more familiar with. And this concept of deploying swarms of micro kind of robots for long duration wide area monitoring is a relatively new one, simply because it's only recently become possible. So thank you very much for listening. Hope that was useful. And for anyone who has more questions that they can't kind of squeeze into the Q&A session, my email is on the screen there, if anyone would like to get in touch. Thank you.
Fantastic. Next slide, please. So I'm Neil Timothy. So I'm Neil Timothy. I'm the CEO and co-founder of Aquocean. I've been working in marine autonomous systems for about 9 years now. Was part of a team that won the Charleston Discovery X Prize looking at hydrographic surveying applications. And one thing I've noticed over the last 9 years of working with USVs is one of the challenges of going from very big vessels and making them a lot smaller, and then realizing that the sea is a very unforgiving place. As Anita has just pointed out, it's not a place that most vessels will survive. And you look at this map, which basically says a lot of areas of operation. You're seeing, this is just from Copernicus on a single day, but you'll see wave heights of well over 2-3 meters around the world. And this actually differs from a lot of trials and testing and evaluation. So when people are trialing and testing a lot of USVs, it's in port and harbor, confined water environments. And the real world is a lot more difficult, particularly in the areas where we look at wind farms. So wind farms are put in areas of high winds for a reason that tends to bring a lot of high sea states as well. So we at Aquocean have been trying to develop a way to keep vessels small, to keep the cost down, whilst keeping some of the capabilities, but still being able to operate in higher sea states, to try and move away from a overcrowding or over demand in the summer periods, and then finding the shoulder seasons being kind of having low usability of vessels. So next slide, please. So when you look at Europe and where a lot of the wind farms are, so Europe is still one of the leaders in offshore wind sector. Asia is picking up quite quickly. But if you actually remember the image in the back, that area around Europe and also in Asia are significantly high sea states. These are not the typical calm Gulf states, Gulf of America or Middle East type states. So if you go through onto the next slide, these are just two quick ones. And we see the same thing when we look to oil and gas and where a lot of the locations of oil and gas, again, a little bit around Europe, but where we're also seeing a lot of interest around east coast of South America. Again, you're operating in those significantly high sea states, and this becomes a real challenge for vessels to operate, not just uncrewed vessels, but also vessels to operate. So if we go on to the next slide, and I can explain a little bit how we're approaching it slightly differently. So what we've developed at Aqua, and we have built it, is a 14.2 by 9 meter SWAT USV. So SWAT is a small water plane area twin hull vessel. It is basically 2 displacement hulls with a fixed draft, and that means the vessel and the waves kind of move through it. So it doesn't have that change, and which decreases the acceleration. Now, where this becomes really useful is in higher sea states is when you start to look at a USV as a mothership. So I will be the first to put up on my hands and say that I think USVs are great, but I think they have limited applications. They're really good at transitioning between the air-water interface. But if you want really high resolution data and at the sea floor, you need an AUV, a glider, or an ROV. If you want to get better high-speed interception from security perspectives, or you want to do wind turbine inspections, you're probably better off with an aerial drone. So what we developed is a modular vessel, can take up to a 6-ton payload in a 20-foot ISO footprint, and then be able to deploy these, launch and recover these various drone systems. Now, stability in that launch and recovery phase is absolutely the most important thing, and I'll show you why in a bit. Again, to Anita's point, persistence is key. If you're going out there for 5 days, it's not really going to be commercially viable, particularly as a lot of these areas are moving further and further offshore. You don't want to be spending your time transiting to and from site multiple times. You want to put an asset out there and collect a lot of data. So trying to get that endurance up. With the new developments we're doing with the diesel variation of the vessel we've already built, we're looking at 40 days endurance. And this, again, it's all about building that power. And then also the other side is comms, because comms, as we all know, is quite a challenging in the marine environment. Smaller assets typically can't put LEO-SATs or Ku-Ka band satellite communications on it. So they tend to be able to deploy RF or Iridium. And where you can actually act as a USV is you can actually start to be able to operate as a mothership to act as a comms rebroadcasting node, as well as maybe a place to offload data, do some edge-based processing using the additional power, and then transmit that on. So next slide, please. So this is what the vessel is really all about. So and I'll touch on this a little bit a bit later, but we are one of the first vessels, well, we are the first vessel to be able to get our MCA Workboat Code 3 certification. This allowed us to go out in August to go out and collect some data. So we went out in, well, let's be honest, the summer was quite calm, not anymore as a lot of storms are passing through, but in the summer it was really quite calm. But we went out in 1.5 and we got up to about 2 meters, I think was the highest wave height we got, 17-knot winds. Had a tug, so we're a 25-ton tug, 14 meters I mentioned, comparing it to a 21-meter, 121-ton tug, which is quite a lot more expensive. Went out and performed some operations in some relatively high sea states that we could get out at the time. And what you should see here is the difference between the pitch. Now, when you're deploying a sensor off the back, ROV, AUV, or anything, it's normally in the aft of a monohull type vessel, and that is impacted by the lever arm effect. So the pitch angle, the forward backwards tilting of the vessel. On a larger vessel, you get a lever arm, and that means higher accelerations in the back. And this means that most operations, even on 50-meter crewed vessel, will stop in 2 meters when they're towing systems or deploying ROVs because of that lever arm effect and because of the pitch. And what you can see here is with the swath hull, you reduce that pitch significantly. So you're receiving about half that pitch. In addition to that, by putting the launch and recovery system in the middle of the vessel, you're removing that lever arm effect. So you're actually getting a massively dampened acceleration for your launch and recovery position. And that should enable us to be able to launch and recover ROVs in up to 4-meter sea states. And we're looking at doing aerial drones to up to 2 to 3 meter sea states with a small platform. That's a way to keep the cost down. And again, Anita's point is, this means you can build more of them, deploy more of them, and you get to that concept of almost like a swarm of swarms. So a swarm of motherships, smaller motherships, deploying a swarm of other robotic systems. So next slide, please. So again, modular container, this is again all about utilization, because again, with all high CapEx assets, you want to increase utilization. That's how you get more, your day rates down, but it also increases your TAM, SAM for the markets, which of course, when you're raising investment is one of the most important things to try and do. So having a 20-foot ISO container allows us to re-roll the vessels. So you can do an ROV operation for a couple of days, 1 or 2 weeks, but then you may need to do some ISR or some wind turbine inspections on an aerial drone. You may also want to do some more security using a towed array. That ability to re-roll the same platform for multi-uses means that you can actually then utilize it, because a lot of these applications are not, some are persistent, like environmental monitoring, but a lot of other subsea inspections or blade inspections will be temporary. So you want to be able to use that vessel more than once in a year. Otherwise, you are tendering for multiple contracts, moving that vessel from location to location, that demob cost becomes quite high. The intention is can you keep a vessel in region and then utilize it more through multiple capabilities? So next slide, please. So when it comes to comms is, as I said, is a major part. So we are actually started a European Space Agency project in September. It's looking at the deployment of small subsea inspection ROVs using a winch system. That is also building out our comms. So comms reliability for command and control is high. We are not an autonomous vessel. We're remotely operated, larger vessel, higher risks, no point to go autonomous since we need to have overwatch and oversight anyway. So what we're developing there and looking at is bonded comms networks. So you'll need more than just Starlink. It's a great step up from where the state of the art has been, but to work towards bonded networks where you can have a OneWeb and a Starlink. So if one goes down, you always have the other. You also have things like service level agreements with OneWeb. That type of optimization of your bandwidth increases the reliability and means that you can stay safely operating. So next slide. And yeah, that's part of our journey. We are as I said, very fortunate. We are the first company to receive WEPO Code 3 certification for our hydrogen-powered vessel. And this means that we're now rolling out to more demonstrations. It's a testament, I think, to the team's efforts to try and get to robust and reliable and safely to operate systems. Thanks. I think that's the last slide. So next slide. Perfect. Next slide. So if anybody wants to contact me, that's my contact details, and I'll hand over to Jamie Williams from Environment Systems.
Thank you. So next slide, please. Environment Systems is a UK SME with over 20 years experience in using Earth observation to better manage the environment. We focus primarily on the terrestrial environment. However, we have undertaken a number of coastal zone projects across the world, so where the sea meets the land. And here's a rapid overview of some of these applied Earth observation case studies to give you a taste of what's possible. Next slide, please. So over the last 10 years, Environment Systems has been commissioned to deliver an ecological mapping of coastal habitats of England. The image on the left shows the extent of where an area mapped between 2019 and 2020. The work involves the use of semi-automated rule-based classification techniques and aerial photography in this instance, such as shown in sensor imagery. We have excessive field validation and quality control, and on the right you can see the resulting habitat classification, which runs the whole extent of the coastal zones. Next slide, please. Agri-environment schemes provide funding for farmers, land managers into farm a way that supports biodiversity, enhances landscape, and improves the quality of water, air, and soil. This project uses existing data with logic flows to assess biodiversity of the total extent of the floodplain, identifying parcels of higher biodiversity importance within the existing coastal floodplain and grazing marsh. Next slide, please. Next, we move on to the Mediterranean, where here we were commissioned to detect suitable sites for algae cultivation. The site selection used additive weighting of surface physical variables and water chemistry to find suitable water qualities. In parallel, we identified optimal coastal sites by assessing topography and current infrastructure. Next slide, please. Next, we move to the Caribbean, where we mapped how the Caicos Islands Ramsar wetland supports biodiversity, coastal protection, and natural capital. The map on the left shows a potential inundation due to sea level rise, and the map on the right shows nature-based opportunities to enhance protection against storm surges. As part of this work, we undertook on-island technical and scientific capacity building to enable better local decision making. Next slide, please. Staying in the Turks and Caicos Islands, a wider study modelled bathymetry using Sentinel-2 satellite data analysis to derive depth measurements. Along with our habitat map, this aided in post-hurricane environmental recovery and enhanced future resilience of natural disasters. So again, there's a strong focus on sharing the experience and learning of the islanders. So the Category 5 hurricanes that you saw earlier in the presentation, these passed by these islands. Next slide, please. So continuing in the Caribbean, we moved to the British Virgin Islands, where we mapped habitat features infrastructure around mangrove sites. We produced maps of the damage caused by Hurricane Irma and the maps of the regrowth at 3 sites since the hurricane. So using Sentinel-2 satellite imagery combined with other data, we then modeled a range of restoration scenarios and mapping opportunities for additional mangrove planting. Next slide, please. So continuing with the theme of coastal vulnerability, Environment Systems carried out a number of projects in the Caribbean island of Anguilla. The map on the left here identifies areas of vulnerability around the coast. And the map in the center shows areas where mangroves can be planted to mitigate that vulnerability. So a nature-based solutions approach to protecting the coastline. And the map on the right shows the impacts of such interventions. So once these mangroves are established, where you're seeing the benefit. Next slide, please. So the resulting work, the government of Anguilla identified 7 priority coastal sites for habitat restoration, including beaches, dunes, and wetlands. Priority action plans for each of these sites have been developed, outlining potential habitat restoration measures, together with hundreds of community members, project partners that we've been working with to implement the action plans, collecting and germinating seeds, air layering woody coastal vegetation, and planting over 1,000 button sea grape red, black, and white mangrove seedlings. So this is applied impact from doing the case studies. So next slide, please. There we go. So all of these projects in some way use Earth observation to derive insights. Therefore, in summary, Earth observation can offer large-scale solutions to specific monitoring needs in the marine environment. It can be combined with other sensors for greater insights and prediction, and Earth observation can also deliver near real-time and historic environmental insights. Next slide, please. That's it. Thank you very much. I'll pass on to Drew Watney next.
Good morning, everyone. Thank you to ESA and Catapult for the opportunity to share our story. My name is Drew Watney. I'm from SAISH and Autonaut. And today I'll talk about how Autonaut is helping build trust in autonomous space-enabled marine systems and where we see opportunities for growth. Next slide, please. The challenge. So across energy and defense and environmental monitoring, the challenge is the same. Harsh conditions, high operational costs, and urgent need for real-time ocean data. Traditional crude approaches are expensive and risky, but adoption and autonomy faces barriers still. Trust, certification, and regulatory acceptance of being the biggest. Next slide, please. Autonaut at a glance. Autonaut is our solution. It's a wave and solar-powered, uncrewed surface vessel, which can operate for months at sea, carry a wide range of sensors, and produce 0 emissions. This endurance and flexibility make it quite unique to the market. Next slide, please. Real-world deployments. This isn't just a concept. We have 6 5-meter Autonots in service in Barbados with BMS, helping to forecast hurricanes. We've worked with SAMS on long-term science missions, which we're currently doing at the moment. And in offshore renewables, Autonaut has supported site monitoring for years now. These deployments prove the platform works and that there's strong global demand. Next slide, please. The next step for us is the 12-meter Autonaut. Currently in development, it has more power, more payload, more capacity, and meets the new MCA requirements. Well, fingers crossed it will meet the new MCA requirements. The model will unlock missions like real-time storm monitoring, hurricane monitoring, and hurricane prevention, early warning, excuse me, and can deliver wide applications in defense, offshore, and wind and security. Next slide. Next slide, please. Space-enabled operations. One back, sorry. Space systems are critical to our story. Autonaut relies on satellite comms for command and control and data delivery. Looking ahead, integration with Earth observation data and satellite AIS adds new value, making the platform even more powerful. Just on this map too, you can see where we had last month, we were operating across most of the Atlantic. We had a boat out in Spain. We had a vessel out in just off the coast of Scotland doing a communications gateway mission. And we had about 4 Autonots out in Barbados doing their weather forecasting. Next slide, please. Barriers and enablers. To unlock this market, we must overcome barriers, certification, regulation, and customer trust. The enablers are here: proven deployments, endurance, zero emissions, and support from programs like ESA. With the right pilots and programs and partners, we can bridge the gap. Next slide, please. Call to action. What we hear time and time again is, can you demonstrate on our shores or in our waters? This is a critical step for us, demonstration campaigns. Supported by ESA and other partners across the industry, we hope to build the trust needed for global adoption. Next slide, please. Was that my last one? Sorry, I might have missed my closing slide there. So in summary, Autonaut is a proven space-enabled autonomous vessel with unique endurance. The opportunities are huge, but trust and demonstration is key. So we look forward to working with you to make this happen. Thank you very much. And the next speaker is Ashley Steer.
Super. Morning all. Thank you to Ori Catapult and ESA for having me. If we go on to the next slide, just the title slide. It's a real pleasure to be able to talk to you all today. Hard to follow those fantastic presentations. So I'm Ashley Steer. I'm Director, Principal Consultant here at Steer Consulting. We're an agile engineering technology consultancy focused on decarbonisation, digitalisation and disruption. We're particularly active in the uncrewed and lean crewed maritime initiatives with a lot of work around assurance and regulatory certification aspects, including kind of regulatory innovation through to helping clients navigate the processes in a more efficient and effective way. So today I'm going to give a brief high-level overview and introduction of some of the regulatory and assurance aspects that we've heard mentioned in previous presentations related to maritime autonomy, with a focus on the smaller smaller surface vessels. Share some context of the landscape, particularly here in the UK, including some of the positive progress being made, and touch a little on the opportunities the technology presents. Although having heard some of the previous speakers and noting the time, I'll try and keep that bit quite brief. I'll also talk to some of the challenges and specifically some of the opportunities around regulatory and assurance aspects. So next slide, please. So by way of introduction, I think we've heard already today significant increase in interest and the adoption of this technology both here in the UK and globally. Unsurprisingly, this kind of rapid pace of development, particularly around automation autonomy, is really pushing boundaries at pace, and that's challenging regulation. As with other sectors, we heard and Pierre mentioned earlier around BVLOS in uncrewed air systems. Regulation is struggling to keep pace, and I think this is emphasised in maritime due to the inherently prescriptive nature of the regulatory ecosystem we're used to dealing with. I've added on the bottom a couple of the definitions. Definitions are important, but when I talk today, I'm talking about remote control and autonomous in the context of how we've got them defined there. So next slide, please. So just by way of a kind of overview of the landscape from the commercial perspective, maritime regulation, the framework for maritime regulation is complex. Maritime is a very old industry, and the regulatory ecosystem has been built up over a significant amount of time. I often hear people say, if you were to write maritime regulation today, you wouldn't start here. So as mentioned, the framework's traditionally highly prescriptive, which works well with incremental change and provides certainty and a relatively low level of technical capability capacity, both on the regulatory side, but also the industry side to respond. This approach can't and won't keep pace with the change and deal with the complexities of the systems that we're dealing with today. Hence, we're seeing a big shift towards more risk-based, goal-based, case-by-case approaches, both internationally at the IMO level and domestically in domestic jurisdictions, including here in the UK. This itself creates challenges before you talk about the challenges related to assuring true autonomy. What I should say is lots of progress has been made and really positive progress made by the MCA, the Maritime and Coast Guard Agency, including the introduction of MGN 664, which is their certification approach for novel technologies, the introduction of Workboat Code 3 that Neil mentioned earlier, which includes an annex on remotely operated vessels, MGN 702 covering sub 2.5 meter vessels, and then MGN 705, which covers 2.5 to 4.5. But there's lots more to do. It's also worth noting that we're seeing specifically an increase in remotely operated vessels initially, and more now pushing the boundaries of high degrees of autonomy or reduced human oversight, for which the assurance aspect is key to unlocking. So next slide, please. So just to try and frame the opportunity, I'll keep this bit really brief. Clearly, there's rapid growth in these sectors, particularly here in the UK, are at a pivotal moment. Global competition's fierce. Whilst we've been a leader, we risk losing that position. Whilst this is very focused on this session's very focused on the offshore wind applications, clearly there's also a significant defence and other applications that are drawing this technology in. Clearly, this technology has safety, efficiency, and sustainability benefits in the way that we do existing activity, but also opens up new markets like Ocean and the hurricane application mentioned earlier. There's a real potential for UK leadership in this space and the associated economic and social benefits it would bring. And as a sector, I think we could do better at articulating what that opportunity is in a consistent and well-evidenced way. So next slide, please. So whilst there's been good progress, as mentioned earlier, there are challenges. And rather see these as barriers, I want to present these as kind of opportunities to do better. This is clearly a multifaceted challenge and is very context specific. As you'll have heard from the speakers previously, this is a really diverse industry looking for different applications, different vessels, doing different things in different places. I think we should see assurance, regulation, and certification as a key enabler to the success of the technology and unlock the operational benefits it can bring. What I've tried to do on this slide is kind of summarize some of the key themes that we've identified that we hear as some of the challenge areas, but also the opportunities that I mentioned. So just to go through them, so the ability to comply with coal regs and SOLAS for smaller vessels. So this is particularly the case where energy is limited to be able to host the communications, the situational awareness. So that is a real challenge area. The administrative burden of certification, especially for the kind of 4.5 meter to say 7 meter remotely operated vessels, that's particularly pertinent. The smaller you get, the more you deviate from being able to comply with the requirements, and therefore the more case by case, the more risk-based certification approach is required, and that drives up the cost and effort. This uncertainty and increased capability capacity demand for risk-based approach, I think it's fair to say it's a step change in capability capacity requirement to deal in a risk-based approach, and industry struggling to make that step into working in that way. Inconsistencies in requirements from different delegated organizations. We do see some inconsistent approaches, and that creates some challenges in the dynamics within the industry. And I think it's fair to say, technical feasibility of requirements for those smaller vessels, actually meeting those requirements is really challenging at that smaller end, let's say that 4.5 to 7 meter range. Challenges with legacy and defense design. So things here that we see is, people who have previously designed and built vessels prior to requirements coming in, now struggling to comply with those requirements, and also where things are destined for defense applications, again, struggling to meet the requirements for what are intended to be commercial vessels. Constraints on early stage testing and demonstration, so the ability to get technology on the water quickly, efficiently, effectively in a kind of controlled environment. You kind of have to jump to full certification approaches rather than that controlled environment to be able to iterate your design and development. That's a real challenge area. I think it's fair to say a lack of maturity of understanding of the kind of software assurance aspects, a really key part of this, and cybersecurity, and that's at all levels of the ecosystem. So that's a really key point that we need to build that maturity in the industry and understanding. We talked a lot about that kind of remote operation piece, but the need for a legal framework to enable effective regulations at the kind of primary, secondary legislative level, really critical to enabling particularly the higher degrees of autonomy to be unlocked. A lack of robust assurance framework for higher levels of autonomy. As I said, there's a real challenge in that space. One piece making the step from a prescriptive to a more risk-based certification approach, and then how do you actually, within that risk-based certification approach, demonstrate assurance of those higher degrees of autonomy? And some great work there being done by the likes of NPL and Lloyds through the MATS program. Ensuring the MCA and government are adequately resourced to enable growth. This is a key part of how do we ensure that the stakeholders in government have the right resource to enable the industry to thrive and enable the unlocking of those commercial benefits. And then obviously there's working collaborative, fostering that engagement between innovation and regulatory functions is critical. This is a co-creation journey, a hand in hand rather than a combative one. So those are just some of the thoughts. So thanks for listening. Feel free to reach out and connect if you want to know more about our work in this space, dive into any of those other areas or how we might be able to support. But next, I'm going to hand over to Deborah Watson, Innovate UK, to talk about some of the funding landscape.
Thank you, Ashley. Can I have my first slides and the next one, please? Hello. So for those that don't know who Innovate UK are, we are the government's innovation agency. We are part of UKRI, which is part of the Department of Science, Innovation and Technology. So if I can have my next slide. As the UK's innovation agency, our role is to help businesses to grow and scale their innovative products and get them to market. And we do that through a whole raft of different mechanisms. If I can have my next slide, please. Most people have heard of Innovate UK because of the funding through the grants they issue. But Innovate also do loans, investor partnerships, and contracts for innovation, as well as a raft of business support. One part of that business support is the Catapult Network, which Julie went through earlier. But there are other parts, and one of those is Innovate UK Business Growth, which I'm going to speak a little bit more about, and the funding that's available through Innovate as well. So if I can have my next slide. Innovate UK Business Growth's role is to work with SMEs, and we do that through a network of innovation and growth specialists based across the whole of the UK. If you can move us on. We work in 3 areas of support, and we do that through that network of people with companies up to 250 employees, with management teams that want to work with us. And it can be businesses that either have or don't yet have Innovate UK grants. So this is sort of an introduction to Innovate UK, or if you're already working with Innovate UK, you can get our support too. If we can move on a slide. The types of companies we work with. This is just one company we've been working with, which is Marine Tech Innovator, using satellite data to look at forecasting water quality and water visibility. So useful for divers, human divers or autonomous ones, looking at offshore wind and other technology areas where you're needing to sort of look at where the water visibility and review what you're going to do there. The other sorts of companies we're working with are companies like Ocean Station Akua, who you've heard from already this morning. So if I can have my next slide, please. The first area that we tend to help companies with is looking at their innovation and commercial strategy, making sure they know what their product is, how they're going to get it to market, how they're going to get it out and commercialise. And we do that through a raft of different areas of support, including looking at intellectual property, access to the Catapult centres that we've already talked about, looking at design, working on British standards, and looking at security. So we can help with a whole array of things, including looking at the value proposition for a company as well. If we could have my next slide, please. This one's currently live and is very relevant to the satellite sector. So innovation security reviews are there, making sure businesses have in place the correct security governance, security culture, risk management, cybersecurity, etc., that is required to make sure their product is safe when they go to market with this. So if you're interested in that, those are currently live, and that QR code takes you to apply for that. So that's £2,500 worth of funded support, £500 from the company, and those are, like I say, live currently. So do go and have a little look at that one. If I can move on a slide. The second area that we help companies with a lot is their funding and finance strategy, making sure we can help them understand what their financial obstacles are, what the opportunities are to secure funding and finance. And we have an investability program looking at investor pitch training and pitch deck preparation. We also help with other areas of government support like R&D tax credits, SEIS and EIS. And we make referrals into the sort of local ecosystem, so the British Business Bank locally or any investment funds that exist in your region. If I can have my next slide, please. We also do support around Innovate UK grants themselves, identifying what's available, but also helping with best practice on applications, identifying partners for collaborative bids and reviewing, doing a critical review of bids. We don't write the bids for companies, but we can help them just review what they have written. That QR code takes you to the Innovation Funding Service, which is where you can find all the current calls. But if I can have my next slide, please. Same QR code. There's not a lot out there at the moment in this sector. The innovation loans are live. Current round closes 22nd of October, which so the new round will be open imminently. So I'm expecting round 24 shortly. If you're doing clever stuff with AI, then access to Isambard AI and Dawn AI supercomputers, there is ongoing support around that. And we do have a global Geo AI build and pitch program that's live with a closing date of the 9th of November. So those ones are out there now. There's also a whole series of bilateral funding calls out there. Horizon Europe, Eureka Eurostars, Global Stars, DASA or UKDI. And I'm not going to talk about the next line because Grant's following me, but there's also funding around ESA, ARIA and others. So there are open calls out there, but not a lot at the moment. And if I can have my next slide, please. The reason behind that is the industrial strategy is only just been launched, and we're expecting a new Innovate UK strategy later this year. That will then drive the funding calls that come out into the next year. So there's a lot coming out of government at the moment. The industrial strategy's 8 sectors are in the little diagram at the bottom there, and advanced manufacturing, digital and technologies, clean energy industries, defence, are all relevant to today's call. So I am absolutely expecting funding calls that will come out that are relevant to today's webinar, because those sectors are absolutely part of the industrial strategy. And just as an example, UK Shore has already been announced. This came out from the Department for Transport on the 15th of September, and that's 448 million coming into R&D for industry around clean maritime. So some of that may well be relevant to people doing the work we're talking about today. If I could have my next slide, please. The third and final area that Innovate UK Business Growth support is helping companies to work internationally, and that clearly from today's companies is critical to their operations. And we help through both global UK partnerships, through the Enterprise Europe Network, which is 65 countries across the globe, and also through our own global innovation programs, where we support GBIPs and GIPs to take small SMEs to international partners to help build collaborations. So that's the sort of third area of activity. If I can have my last slide, just to talk a little bit more about the Global Business Innovation Programme. These are bespoke programs of support, and we do have a marine one in South Korea as we speak. And I know there are some, and I think there's about a dozen companies from the UK in South Korea now talking about marine and partnerships in South Korea. My final slide is just another example of the sorts of companies we work with, which is a company called Hydroserve. They are in South Korea with us currently, and we've helped them over a period of time revamping their IP strategy. They established a Canadian subsidiary after going to Canada with us, and I've also been doing some work with us in Singapore because they're looking to internationalize their offer. If you're interested in more about them, that QR code takes you to a success story on Hydrosurf. And like I said, we've also been working with Ocean, Sage, Akua Ocean, and a number of other companies working in this space. So if that is you and you're not already engaged with the business growth team, I think my final slide is my contact details. So do get in touch, at which point I think I hand over to Grant, our last speaker of the day. Over to you, Grant.
Thank you very much, Deborah, and thank you, everybody. I appreciate the contribution from all our speakers, but also the your patience with us, but we've run slightly over. I think it has still been worth running over. I appreciate some people might want to jump off, and that's fine. The session is being recorded, so you can catch up to this last little section at a later date. I'm going to quickly do a summary, but I will try and keep that brief. I think both in our previous work that we've done with the Catapult and going through this, there's sort of two key tracks that we're looking at where there's an opportunity for space-enabled data and solutions to contribute within the offshore world, but there are some bigger constraints within that. One of them is being consenting, and we can see within that highlight that Julie opened with, the fact that it takes longer to consent than it does to build a site is obviously a significant challenge. And that still comes down to a lot of the big thing that's been repeated a lot today, which is around that uncertainty and how do we manage uncertainty and how do we meet the regulators halfway. I really enjoyed the way that Ashley pronounced it in terms of referring to challenges and opportunities rather than being the problem with regulators. There is a good, exciting opportunities in there. And I think that's also reflected in terms of the O&M challenges and the opportunity that space-enabled robotics provide with regards to O&M. I think it's a slightly more mature side of things in terms of what exists both in the market already, but also the regulatory work that people like Ashley have really done with the MCA in order to enable mini-mass and other type opportunities. I'm going to quickly cover then, well, all of that's to say, the point of this webinar was to try and drive some understanding from you, the audience. What are the particular challenges within that you'd like us to address? So we're hoping to host, well, we're intending to host 3 more in-person events. One in Wales, looking probably more around the consenting challenge. One in the Southwest, probably Plymouth, looking at the marine autonomy, probably in quite a more general perspective, partly due to the, I guess, the strength of expertise in the Plymouth area around marine autonomy. And then one in Grimsby looking very specifically at O&M, and we'll be looking to host those in February next year, which sounds like a long way away, but we'll creep up very quickly, I'm sure. Next slide, please. Thank you. So ESA Space Solutions, Mina did a really good job earlier of introducing what ESA Space Solutions from an energy perspective. I'm going to try and touch that slightly more broadly in terms of what it's all about and how the sorts of things that we're trying to fund. So we sit within the commercialization directorate within ESA, which is all about how do we use space assets for the better of people and planet. We're much more focused on actually how do you validate technology. And there's a whole bunch of stuff that comes with our funding. So funding is anywhere from €50,000, officially no max amount, but once you go above 2 million, there's a lot more challenges in terms of the timelines of the approval. So sort of a soft limit at about €2 million. But it comes with a whole bunch of stuff in terms of support and guidance. And crucially, the credibility of being able to do your project with ESA. Next slide, please. As always, this is a slide I have to repeat a lot. As a space agency, there does need to be a space asset involved in your solution, whether that's Earth observation, navigation, comms. But I think there's very few companies working in this domain that isn't using navigation or comms in some domain. And for us, crucially, you do need to be doing something with that data. So the data in itself is fine, but actually we want you to be doing something useful. And then most importantly, as a commercialization program, we're very interested in how you can express and understand the specific requirements within your markets that you're doing something that effectively that people will buy. Next slide, please. So this is a quick snapshot of some of the energy-related activities that we've done since 2018. I've been in post since 2022, and energy has dominated quite a bit of my work. So we've done quite a bit around those 4 groupings of topics that Mina mentioned. Myself and Julie did a workshop earlier this year around digital solutions for the energy sector. I'm very pleased that that has led to some really good applications. Similarly, early in 2024, we did a program around robotics in energy, and that has produced some really good results and some working in ahead. It's useful to understand the way that ESA fund things. Next slide, please. And there's some little bit of complex. Sorry, I have highlighted there the website to where to get projects. We've got an extensive portfolio, and I will touch on that earlier, but that is a useful topic. So we do tend to fund things in two different tracks. There's a little bit of complexity to these, but I'll try and make it clear. So starting from the bottom, we have our invitations to tender. These are competitive programs that are European-wide, and they tend to be in two strands, either the kickstarts, which are basically 75,000 euros funded at 75%, so 100 euro projects, really designed to quickly and sharply test the market and test the viability of something. And then our feasibility studies, which are slightly more involved, but they're on a competitive basis, typically at the 80% funding. And we have one example that I'll mention shortly on feasibility studies. And then the other thing that we fund is via our direct negotiation program. And these are then non-competitive, and there's a lot of flexibility. For me, the biggest advantage with ESA funding is that even on our thematic calls, we don't prescribe scope. The idea of that being is because this is a commercialization program, we want you to tell us where you see the opportunity, and it'd be dangerous if we were to overly dictate via scope. I'll touch on two examples of both the direct negotiations and the invitation to Kickstart in terms of how it works, and then probably more useful some relevant case studies, which I'll rush through, but I think are important to highlight. So next slide, please. So this is an example of one of our competitive ITTs. So this is an invitation to tender around green hydrogen as a sustainable energy source. It opened early this month and it shuts relatively early next month. And this is all around understanding the viability of a service. So it's much more focused on how do you evaluate, understanding the very specific requirements that your customers might have, and how do you then build that out into something that's usable. Particular sectors that we're expecting applications around: energy, transport, maritime, and smart cities. ESA will co-fund 80% of the acceptable costs, so up to 200,000 euros, meaning total project size of 250,000 euros. The link below there is live. This is a current opportunity, and we would encourage you to look at. Next slide, please. I mean, this is always a very challenging one to get people excited about, but actually this is probably, to me, the most exciting program, which is our open call for proposals. That's within our direct negotiation program, looking for both feasibility studies in and up to 500,000 euros and demonstration projects up to 2 million euros. Feasibility studies are there to help you identify, analyze, and define services, really looking at, is this commercially viable? And then our demonstration projects are all about the implementation, so the design, build, test, and for us, crucially, validating with your customers that it provides the value that you say it will, so that hopefully more people will buy. It's always useful if you can give some examples of each of those. So if you can move on to the next slide, I've got 3 very quick case studies, all related to floating offshore wind, that I think might be useful. So first one is a ongoing feasibility study, the company called Dublin Offshore, so not quite UK, but is focused on the Celtic Sea. They have a load reduction device that they're looking to take to the market. And they're really looking to use that load reduction device to reduce fatigue in the mooring processes. And they imagine, well, they are working towards providing a 30% capex reduction in mooring based on the optimum usage of their load reduction device. So the purpose of their feasibility study was to really evaluate a number of different spaceborne assets that would allow them to optimize the peak performance of their load reduction device, looking at both spaceborne scatterometer, synthetic aperture radar, both the commercial and the free SAR via Sentinel-1, and a bunch of meta-ocean data. And there's a nice combination of both looking at what is the optimum performance, what's the optimum satellite-based data to optimize performance, but also comparing that to then how to make that financially viable, or looking to make sure that they are able to provide that 30% reduction in mooring capex. So a nice example of an ongoing study in not just building the device, but how do you use satellite data to optimize it and provide the the benefits to this sector that we're hoping to. Next slide, please. So this is a company I think most people on the call will be aware of, Silmara. This is a completed feasibility study looking specifically at decommissioning. So it is using uncrewed vessels being controlled from a land-based remote operating center. Again, this is a feasibility study, but they were looking at 4 sub-services within decommissioning. So inspection, repair, and maintenance, an emphasis on decommissioning, so the pre-decommissioning, post-decommissioning, and then ongoing monitoring, as well as then site service and remote access. But again, satellites play a key role, both in terms of GNSS, in terms of positioning, but also the SATCOM requirements for this. Their feasibility study was really looking at, for all of those use cases, the volume and the accuracy of that data. How much would that then cost them to run that as a service and allow them to make that a viable decision? Does this provide what the market needs? I'm pleased to say that they have completed that feasibility study, and are now moved on to a demonstration phase where they're looking to implement this technology. And then one final case study, please. Next slide, please. So this is then our demonstration project. So that slightly larger scale project, looking at doing that implementation. So this is from AAC Cloudspace, based up in Scotland. I think the Catapult are partners on this, along with Strathclyde University and, I did write it down, and Trails Renewables. This is looking at the implementation of providing situational awareness for maintenance ship operators, specifically within complex wind farms. Using a combination of data, so their own AIS constellations as well as the terrestrial AIS networks, a combination of commercial SAR and free SAR, particularly looking at vessel identification as well as turbine angle, and then looking at that combined with sea state models, so the in situ buoys, the Sentinel-1 free SAR, and Met Ocean data, to really do a really detailed service planning tool to allow that cost-effective planning for construction and O&M activities, as well as providing increased security. So hopefully these 3 case studies give an understanding of what our feasibility studies are trying to do, as well as what our demonstration projects are trying to do. My last final slide is just a bunch of links, so I don't need to talk you through those. Really just to point you in the right direction for each of the things that we've spoken about today. I'm mindful that we are somewhat over time, so we'll probably draw to close here. We will send the slides following this, but we're very, very keen to make sure that the workshops that we do in person next year in February are really purpose driven. So if there's a topic or a challenge that you've come across us today that you would like us to engage in more, the purpose of those workshops are really to help crystallize and understand the specifics of those challenges and the problems, so that when you apply to Innovate UK or ESA or elsewhere, that actually your proposals have a much stronger chance of being successful. So I think we shall leave it there and say thank you very much. Julie, does there anything else that you wanted to cover?
Not at all, thank you. That's a brilliant summary, Grant. And as Grant said, please get in touch, because we do want those in-person events to be meaningful and well centered around the issues that matter to you. So thank you very much for everybody, and Olivia, thank you for running it so well. Bye.